Hello everybody, today we are going to be doing a quick problem here. This is going to be called the two-sum problem. It's a very common interview question and coding question in general. So yeah, let's go through it. Basically, we're given an array of integers, nums, we'll call it nums, and an integer target. What we're asked to do is that we're supposed to find the indexes of two different numbers such that they add up to the target. You may assume that each input has exactly one solution, and you may not use the same element twice. You can return the answer in any order. Alright, so essentially we can take a test case here, for example. So for example, if we have, I'll just keep it in the comments. If we have the numbers 2, 7, 11, and 15, and we're trying to give the answer, trying to get 9, basically all we need to do is we need to return 0 and 1, because 0 and 1 in this array are the two numbers that together add up to 9. So yeah, that's basically it. Yeah, if we don't want anything, we just we'll return a blank array. Like for example, if the answer was 12, there's no way to get 12 from any of these numbers, so we would just return none in that case. So in that case, we'd return none. Alright, so let's start by creating the problem. And there are definitely multiple ways to approach this problem. One thing you could immediately tell if you're somewhat experienced with coding, one solution would just be to loop through every element, subtract whatever the target number is from the element, and then keep that in track, and then continuously loop over and over until you find two elements that add up. So that would be an n-squared solution. However, the problem with that is that it's a little bit time complex. So in like a very large array, that would be inefficient. So the way we're going to be doing it is using a hash table. So a hash table is a special type of data structure. In Python, it's also known as a dictionary, and it is basically a hash table or a dictionary in Python utilizes key value pairs, and then it runs a certain algorithm so that whenever we're trying to look up a specific value in this dictionary, you can do it almost immediately. Whereas, for example, in an array like this, if we're trying to find the number 11 in the array, we'd have to go one by one, 1, 2, 3, all the way up until the entire list. So that would be an n complexity time. However, in a dictionary, we can do this in a time complexity of 1. So that saves us a lot of times. So how we're going to start by solving this problem. First, we're going to say for I comma num in enumerate nums. So what this does is it is actually going to be taking num and I is going to be the index, and num is going to be the actual value of the array. So remember, nums is a list, a Python list. I gives us the index, whereas num gives us the, sorry, is it this way or is it the other way around? No, it's this way. Num is the actual value in the list, whereas I is going to be the index of that. So it's going to return those two as I and num in the entire list. So it's going to be looping through this whole thing. So the first thing we're going to do is we're going to set a complement variable. Complement is equal to target minus num. So what this complement does is, for example, let's use the 9 example. It's going to first see 9 minus whatever num it is. So it'll always start off with the first index, which is I is 0, num is going to be 2. So to calculate the complement, we just take the target, 9 minus 2, 7. So the complement is going to be 7 here. And then what we're going to do is we're going to look up if the number 7 was already in the lookup. So if complement in lookup, if we know that it's there in the lookup, that means we have a match. So we can just return lookup of complement, comma, I. So this is going to be in the dictionary, lookup of complement, which is going to be what we're going to be storing in this dictionary is going to be the number in the list corresponding with the index, basically. So we're going to be returning the index of 7 and I, which is going to be the index of 2, for example, in this first list. Well, not in the first step, but it's going to be in the second step. So after it does this, we can simply say, so if we don't find the complement in the lookup, we're going to add it to the dictionary. Lookup of num is equal to I. So we can go through the first iteration real quick for I, num, and enumerate nums. First it'll be I is 0, num is 2, complement is equal to 9 minus 2, which is going to be 7. If 7 is in the lookup, it's not. So if 7 is in the lookup, it'll return it. But since 7 is not in the lookup yet on the first iteration, we'll do lookup of 7. Lookup of the num, which is 2. Lookup of 2 is equal to I. So we're going to be storing the key value pair of 2 and I, which is 0. So it's going to be storing the dictionary value of 2 and 0. Next it goes on to 7. Complement is calculated by target minus the number, so it's going to be 9 minus 7. Complement is 2. And if the complement is in the lookup, which it is on the second iteration, because we just added 2 to the number, it's going to find 2, and then it's going to take its index and return it along with the current index. So that's going to return 0, 1. So that's just one example. Hopefully I did that all just by speaking. It might have been easier to do some visual thing, but I couldn't really do that right now. But hopefully you got it based off of just what I said. And now, if you couldn't find it, we're just going to be returning none. And yeah, that's pretty much it. So let's run some test cases just to see. We're going to set nums is equal to, let's put an array, 2796. Target is equal to 9. And then we're going to print TOSUM of nums, comma, target. So let's run this code, and if we did everything right, it should be giving 0, 1. No, I got an error here. Complement, I think I misspelled that. Yeah. I think my IDE is having some issues today where no error lines are showing up, so I didn't catch that. Okay, but yeah, we ran the code, and I can run it again just to show you guys. 0, 1 appeared because 0 index and the 1 index get to 9. We can do another test case. Let's take for example, this one's a longer one. Like that. And the target is going to be 5. To get the two-sum problem right here, what you'd want to do is take this index and this index, so the response should be index of 0, 1, 2, 3, and 0 and 4. So it should return a list of 3 and 4. I can print this out, run the code. Sorry, I didn't save it, so it probably didn't go, but yeah, 3 and 4. Alright, let's just do one more test case. How about this? And then we're trying to find 10. This one is, once again, we're going to find 0, 1, 2, and 3. So it's going to be 2 and 3 because these two numbers add up to get to 10. So save it and let's run it. And we get exactly 2 and 3. So we can see that the code worked here. Hopefully you guys understood exactly how this efficient solution worked using the dictionary or hash map and the looping through the nums array, and you hopefully understood my explanation of how we iterated through it to get to this solution. Alright, thank you guys so much for watching, and I'll see you guys in the next time. See ya.